We're going to explain how to split a dataset into batches. This is a crucial step in many machine learning tasks, especially when dealing with large datasets that won't fit into your computer's memory all at once. Batch processing allows you to train your model on smaller, manageable chunks of data. Here's how you can do it, covering a few common approaches. 1. Understanding the need for batching. Large datasets often exceed the available RAM, leading to memory errors. Batch processing divides the data into smaller, equally sized subsets, batches. Processing one batch at a time allows the model to learn from a portion of the data, reducing memory usage. Manual batching, using Python lists. This is a straightforward approach for smaller datasets. Imagine you have a list called data, containing your dataset. You can split it into batches of batch size like this. Batches elt data I plus batch size for I in range, 0, len data, batch size, at. This creates a list of lists, where each inner list represents a batch. For example, if data has 100 elements and batch size is 20, you'll get 5 batches. 3. Using NumPy. NumPy provides efficient array manipulation. If your data is in a NumPy array called data array, you can use np.array_split data array num batches to split it into a specified number of batches. Alternatively, you can specify the batch size, and NumPy will calculate the number of batches. 4. Using TensorFlow Keras. These frameworks handle batching seamlessly. When you load your data using tfdata dataset.from tensor slices, you can then use the batch size budge method to create batches. This approach is highly efficient and handles data shuffling and prefetching automatically, optimizing training performance. This means that it automatically shuffles the data and loads the next batch while the current batch is being processed, minimizing idle time. 5. Using PyTorch. Similar to TensorFlow/Keras, PyTorch offers data loaders that simplify batching. Torch.utils.data.dataloader takes your dataset and batch size as input, handling the splitting and iteration. You can specify a shuffle parameter to randomize data order for each epoch. This ensures that your model sees different subsets of data in each training iteration, preventing bias and improving generalization. 6. Handling uneven batches. Sometimes, the last batch might be smaller than the others if the dataset size isn't perfectly divisible by the batch size. The methods mentioned above will handle this automatically. You'll just have a smaller final batch. In summary, batching is essential for managing large datasets during machine learning. Choose the method that best suits your dataset size, framework, and needs. Whether you're using manual list manipulation, NumPy's array splitting, or the built-in batching capabilities of TensorFlow, Keras, or PyTorch, remember to select a batch size that's appropriate for your system's resources and training requirements. Experimentation is key to finding the optimal batch size for your specific task.